Okay, Assalamualaikum. We are from Group E Ahmad Najmuddin, Muhammad Faizal, and Danish Nazmi. We will present about Chapter 3, Application of the Differentiation. Okay, the table of the content, we have Introduction, Application of the Differentiation, Problem Statement, Objective, Problem Solution, and the Conclusion. For the introduction, the topic that we'll present is applied maximum and minimum problems. At the end of the chapter, we will be able to understand applied maximum and minimum problems. And then we will understand we can solve maximum and minimum problems by knowing to use the suitable formula from the geometry formula.
Okay, the differentiation in mathematics is the differentiation of our project. The differentiation in mathematics is the process of finding the derivative or rate of change of a function, in contrast to the abstract nature of the theory behind it. The practical technique of differentiation can be carried out by purely algebraic manipulation using three basic derivatives, four rules of operation, and a
When do
knowledge
we apply
of how
differentiation?
to manipulate
First, to calculate the
functions.
profit and loss in business using graph. Second, to check the temperature variation. Third, to determine the speed or distance covered such as miles per hour, kilometer per hour, and others. Derivatives are used to derive many equations in physics. And lastly, in the study of seismology, like to find the range of magnitude of the earthquake. Other application in derivation. First, differential. Second, concavity and the second derivative test. Third, curve catching. 5, derivatives and the shape of the graph. 5, the mean value theorem, Rolle's theorem, and monoplicity. 6, maximum and minimum values, and others. Situation problem. I have a rectangular flower garden with an area of 45 meters square is surrounded by a grass border of 1 meter wide on two sides and 2 meter wide on the other two sides as shown in figure below. Let x and y be the length and width of the flower garden respectively. Najmuddin, can you show me that the combined area of the garden and the border is A equal to x plus 180 per x plus 53?
Okay, so the area flower garden, you will get 45 m squared. Okay, for the area flower garden, you must time x times y equal to 45. Okay, so if you want to find the width of the flower garden, it will be y equal to 45 divided x. After that, area of the garden and the border. So this 80 is area of this big rectangular. Okay, so you must time the length and the width. You will get 8 plus 4y plus 2x plus xy. After that, after you get this equation, you must insert the value of the y, and you will get the area of the flower garden and the border is 2x plus 180 divided by x plus 53.
Nazmi, how about the dimension of the garden will minimize the combined area of the garden and the border?
Okay, I will show you. As we know, we need to differentiate the area combined of garden and the border. After we differentiate the equation, we will get 2 minus 180 times s power of negative 2. Next, the answer we need to equal with 0. After that, we do as usually. Then we will get plus and minus power of power root 90 meter.
Najmuddin, can you find me the minimum combined area of the garden and the border?
Okay, so if you want to find the minimum combined area of the garden and the border, first you must differentiate one more times the area of the garden and the border. So after you differentiate one more time, you will get 360 x cubic negative cubic. Okay, if the value x that you get is more than 0, so it will be minimum area. And if the value of x that you get less than 0, that will be maximum area. Okay, you asked to find the minimum area. So you must take the value positive, search 90, and insert it to the equation. It will be 2 times search 90 plus 180 divide search 90 plus 53. And the value that you get will be 90.95 meter square.
So, conclusion from this project, we can conclude that our objective in this project reach. In applied maximum and minimum problems, we have a few common questions that will be asked. For example, from our question A, we need to show the combined area of the garden and the border. How we solve this problem, we must plus the area of flower garden and the border. For B question, we need to find dimensions of the garden that will minimize the combined area of the garden and the border. We need differentiate the area and find x. Last question, C, is finding the minimum combined area of the garden and the border. First, we need differentiate the area from question B and fill in with x value that we get. So, thank you.